Welcome to the Latvian Institute of Aquatic Ecology. It is currently an agency of Daugavpils University and it has been founded 25 years ago, in 1995. Since 2015, this is our headquarters on the bank of the river Daugava. The building itself has been specifically designed for laboratories and offices. Laboratory for pretreatment of biological samples have been recently acquired. Our location gives us opportunity to reach the Gulf of Riga in a half an hour for sampling and measurement purposes. Our research directions and infrastructure cover following areas: oceanography, benthic and pelagic ecology, hydrochemistry, biological effects of pollutants and microplastics.
So here we can see CTD probes. CTD probe is probably the most common oceanographic instrument used nowadays, and you can use it in different applications depending on your research aim. So in front we can see these two CTDs. They are mostly meant for continuous measurements at a specific place. You can get good data with good time resolution from one specific place. Then at the background, these two are quite similar, and these are mainly used for vertical profiles. So you can get the data about the whole water column. So these two we mainly use for scientific cruises in the Gulf of Riga. So we can get many profiles out of them and get more thorough analysis about the dynamic processes in the water. So let's go further. Here we have a Adcp measurement instrument, and Adcp stands for acoustic Doppler current profiler. So this is the instrument with whom we can measure currents. Practical measurements in the Gulf of Riga are rather scarce in the recent times, so we are now quite extensively doing some measurements at coastal regions of the Gulf of Riga. Next step is to do it in the greater depths. Also, our institute is involved in one international project called Cable, where multiple countries around the Baltic Sea will measure currents in the Baltic proper, and it will happen next year in 2021. So basically this Adcp instrument is deployed in the middle of this platform, and then on the sides of this platform we can mount some additional CTDs, as I already showed you before. So we can put together a nice system which gives us more information about water characteristics. So here we can see our two smart buoys waiting for deployment. One is scheduled for deployment in the Pāvilosta city and the other one close to the Irbe lighthouse. So the buoys are equipped with CTD, multiple sensors, current sensors and wave height sensors. And altogether they are working in a unified system and sending the data once per hour. So this is the first such application using smart buoys in the Gulf of Riga. So when these two smart buoys will be deployed, they will send data once per hour as continuous measurements, which we will receive through our data system, and we will see it in our interface. All the results will be available for everyone.
Benthic habitat investigations encompass extensive fieldworks. Researchers are operating from high-speed motorboats or research vessels depending on the distance from the shore or the nearest harbor. Main tool for investigations of benthic habitats is underwater video camera. It is equipped with 3 thrusters for the horizontal and vertical movements of the camera to ensure the smooth approach to the object. Camera has also light systems with the LED panels surrounding the cameras to ensure the scattered light in the background. Camera can operate from 0 to 70 meters depth, thus covering all the depth range of underwater habitats necessary in Latvian coastline. Camera is operated from the surface using the console. underwater video camera ensure valuable information on the state of the benthic habitats. However, the samples for the biological samples have to be taken manually using scuba divers. Latvian Institute of Aquatic Ecology has a team of 6 well-trained scientific divers. They are starting their education under Professional Association of Diving Instructors as advanced open water divers, performing dives till 30 meters depth. They are completing their skills in the institute under the supervision of elder divers. Competences necessary for the underwater sampling and operation of equipment. Divers are operating in the dry suits equipped with half-wing buoyancy control devices. Divers are using regulators designed for cold water immersions to avoid the free flows under the water.
The microscopy laboratory is specifically equipped to provide all the needs of pelagic research, mainly covering phytoplankton and zooplankton identification for a wide size range. It has 2 inverted microscopes. Both are equipped with a digital camera, providing live image and enabling creation of micrographs. They have magnification possibilities from 100 to 1000 times, and they are suitable for analysis of unicellular organisms, phytoplankton and microplanktonic protozoans. They have common transmitted light contrast techniques, bright field, phase contrast and polarization technique. Also, they are equipped with a 5-position fluorescence turret and a mercury lamp, accommodating fluorescence technique. Usually, bright field and phase contrast technique are used to analyze phytoplankton and microplankton samples, whereas epifluorescence is used for pico and bacterioplankton enumeration. An upright microscope ensures technical capability for analysis of larger organisms, such as metazoans. It has fully automated transmitted light access for common contrast methods: bright field, dark field, and phase contrast. It has magnification possibilities from 25 to 1000 times. It is equipped with a digital camera, providing live image and enabling creation of publication quality documentation in form of micrographs. Usually it is used for zooplankton sample analysis, that is taxonomical identification and measuring of organisms, but sometimes it is used for other specific tasks, for example, microplastic detection. Besides plankton, pelagic research also includes estimation of chlorophyll A concentration. It is mainly conducted out in the field on board research vessel with the respective limitations in sampling frequency. Therefore, the pelagic team constantly follows the advancements in research methods. Since year 2018, Latvian Institute of Aquatic Ecology, in cooperation with the Joint Research Center of European Commission, manages bioptical equipment as a part of aerosol robotic network, also known as Aeronet. It is a multi-spectral photometer situated on the Irba lighthouse, and it provides continuous measurements of sky irradiance, downward radiance, and water-leaving radiance, and provide data for validation of satellite products, for example, chlorophyll A estimates.
The activities of different industries and minings, as well as usage and release of metals to environment, are increasing year by year. The result of this is environmental pollution with toxic substances, including metals. Metals can accumulate in the food chain and can cause toxic effects to biological organisms and the death of these organisms. This laboratory has been set up for metals determination in sediment, soil and aquatic organisms. It's equipped with a microwave oven for sample preparation by digestion with acids and 3 types of atomic absorption spectrometers, with flame atomization, electrothermal atomization and mercury analyzer. In our laboratory, it's possible to analyze various metals. The metal has hollow cathode lamps for several elements such as copper, zinc, cadmium, nickel, lead, chromium and other toxic elements, and supporting elements depend on research need. Laboratory is accredited according 70025, and to assure the quality analysis, laboratory regularly successfully has taken part in international comparison exercise in the frame of the program Quality Assurance of information for marine environmental monitoring in Europe, quasi-MEME. One of the most toxic metals is mercury. Interest in mercury pollution and its toxic effect has increased since mercury poisoning in Minamata. Elevated levels of mercury in fish and shellfish around the world have been well documented. Environmental problem for many years. During methylation process in sediments, methyl mercury becomes bioavailable for aquatic organisms and due to its lipophilic properties easily accumulate in the food chain. Predatory fish, birds and mammals as well as humans are most affected by mercury pollution. Teledin Lehman Labs Hydra 2C analyzer is automated analyzer that measures total mercury in diverse solid, semi-solid sample matrices directly without sample preparation. The system employs the technique of sample thermal decomposition, mercury concentration via gold amalgamation, and detection by cold vapor atomic absorption. The advantage of this method are small amount of the sample and excellent sensitivity allow to analyze small organisms, for example amphipods. No sample preparation required, thereby time saved and no waste generated. Wide dynamic range, the signal is measured in series by high sensitivity cell followed by a low sensitivity cell. Matrix independent calibration and measurement. Sample cycle stages are computer controlled for easy use. In our laboratory, mercury cycle is used for mercury determination in sediments, soil, fish, shellfish and small aquatic organisms. Microwave acid digestion is a technique to dissolve metals bound with a sample matrix such as sediment, soil and biological tissue into liquid. This is achieved by exposing a sample to strong acids in a closed vessels and raising the temperature and pressure through the microwave irradiation. Both the speed of thermal decomposition of the sample and the solubility of the heavy metals in solutions are increased. Once these heavy metals are in solution, they can be quantified by atomic absorption spectrophotometers used in our laboratory. Microwave oven Mars 6 is used for sediment, soil, fish and shellfish soft tissue sample digestion. Total Organic Carbon Analyzer is a recent addition to our equipment park. It allows us to measure various forms of carbon in liquid samples, so enabling widening of our research activities. Its particular importance for our scientific interest in the Gulf of Riga since it receives inflow of river waters rich with humic substances. The alteration of carbon cycle due to climate change and anthropogenic activities is also part of our future research interest and this equipment will facilitate. Shimadzu TOC-L analyzer is intended also as a multi-purpose tool as it is fit with total nitrogen module allowing us to perform carbon and nitrogen analysis in the same sample.
Laboratory is dedicated to the estimation of biological effects of contaminants. Enzymatic reactions in aquatic organisms respond to the presence of such pollutants as polychlorinated biphenyls, polyaromatic hydrocarbons or pesticides in the environment. Enzymatic reactions are measured using SPARC multi-purpose microplate reader with absorbance, fluorescence and luminescence modules. Currently we are measuring enzymatic reaction in absorbance mode, but other methods used are ELISA tests, protein quantification, fixed wavelength fluorescence measurements in fish bill and algae bioluminescence and cell count.
The Institute has developed a specially equipped laboratory designated for microplastic research, as well as ensure the possibility to analyze samples visually and chemically. We are looking into microplastic pollution in two main matrices, water column and sediments of marine and freshwater. Sample treatment includes work with toxic substances. Therefore, we have a fume hood that diverts harmful gases outside from the laboratory, providing safe work environment. To ensure the quality of work, we are performing sample treatment in laminar flow cabinet. It provides us the necessary clean environment to exclude any possible sample contamination. Several sample preparation steps require heating and mixing of the sample. For this purpose, we have water bath equipped with necessary functions. Sample visual analysis is performed using either microscope or binocular, combined with lake camera and lake application suite software. Using this equipment in microplastic research, we are able to determine the characteristics of microplastic particles, such as shape, size, and color. We have a multifunctional Thermo Fisher Scientific Nicolet ISO 20 spectrometer that can be used to identify a variety of materials and substances. It has two accessories: transmission accessory for making quick and accurate measurements of liquids, solids, or gases, and reflectance accessory to analyze polymers, additives in plastics, pharmaceuticals, and volatile liquids. Reflectance accessory is used together with attenuated total reflection or ATR sampling technique and Omnic software. After scanning the object, in this case a microplastic particle, acquired data is shown on the screen and automatically matched against the spectral database of known materials. As a result, the best compatibility is presented. Our database consists of 30 libraries and more than 15,000 spectra.